Okay, I'm going now through briefly through the automated reconstruction process. This yields good results only in particularly noise-free image stacks, and in any case the reconstructions have to be corrected manually afterwards. I'm starting again at the point where we left after video tutorial 1. So the two image stacks here have been loaded already, and we've set the voxel size, etc., and alignment in the stack panel. So we immediately go on to the thresholding panel, which is this blue panel here. There are essentially two ways of thresholding the images. One is what I call the dynamic or local thresholding, which it gives a threshold that is different for any location. So in an area in which the overall brightness is smaller, the threshold will be smaller as well. And the value that is set here is automatically calculated when loading the image stacks, and is a good default value for this. So we can just press this thresholding button here, and it will do this dynamic thresholding for each image stack one at a time here. And we see that it did a pretty good job. The user interface actually added some blue tiles where the threshold, where onto the parts of the image which belong to the thresholded area, and see that it did a pretty good job. Now if I untoggle this dynamic button here, then I could set a direct absolute threshold, brightness threshold value, which typically I would have to choose wisely according to the brightness values of the image. So if I actually look at, for example, here, I can add the color bar, I see that the typical brightness values go from 0 to 250, so maybe, I don't know, 100 would be a good threshold value. I'm not going to do this. I'm now continuing, and we see that there are still a few small areas that were included in this thresholded image. We can get rid of these by using this clean button on this thresholding panel. This clean button actually has sort of a threshold value. This means that everything that are connected pieces that are altogether smaller than 100 voxels will be cleaned away. So I can press this button and you will see all the small dirt here is now gone. Of course, some of the real dendrites branches are gone as well. The next point is to skeletonize this thresholded image. That's in this skeletonization panel, and this green panel here. There's the skeletonize button, which is just the first step of the skeletonization process, and you just have to press it, and you will see how this results into the carrier points of this thresholded image. So that's also done individually for each image stack, but you see that these green points lay on the morphology, and they are sort of the carrier points on which we will grow the tree. Now there are some areas where these green points are extremely dense, so we can clean this and say, for example, anything that's where two points are closer than 1.5 micrometer to each other, then one of the 2 points, the one that's less bright, will be eliminated, and you can just press this clean button and you'll see that only a few points remain. We can also automatically look among those carrier points which one could be a soma. There's a soma button here, and it finds this this one here as being the soma because it's the point where this thresholded image is the largest. This has actually a threshold here which we can actually change. So I'm can, for example, put it down to 1, press this button again, and then it will find many more. But the first attempt was much better, so I'm just going to clear all the somata again, and then put the threshold back to 5, and then press the soma button again. Additionally, we can also calculate a graph. I'm clicking here, which says how likely it is that two of those points are connected to each other, and that is calculated such that you can actually, they're connected if you can go from one point to the next via the thresholded image. So that's a simple way to calculate it for now, and extendable in future versions. And now we're actually ready to build the tree, which is this MST button, and you see this is already in this red panel, which is the actual tree edit panel. I'm just going to grow the tree onto these carrier points using this extended minimum spanning tree algorithm that I have developed, and you can already see that it grew the tree onto these points. Now, in order to get a little bit of better overview, I'm just going to get rid of all the graphical elements. So for this graph, I can get rid of the graph, I can get rid of the soma location, the skeletonized points, these green points, the thresholded image, and I can get rid of the color bar, and I can change the color map, for example, to the inverse hot color scale, which I think gives a better impression of what happened. So you see it did a relatively good job, but of course it's not perfect. There are a lot of things that have to be corrected, and there are some automated ways to correct these, and there are some manual ways to correct these, and this will be part of other tutorials.